traffic management becomes an essential foundation in the modern world of network digital systems, where data flows like a complex web. The strategic coordinations and optimizations of data flow inside the network structure is the fundamental definition of network traffic management. It includes a wide range of methods, tools, and approaches designed to guarantee the dependable, safe, and effective transfer of data across networks. Envision a congested highway network during times of high traffic, where different car types, speeds, and destinations compete for available space and bandwidth. This digital highway is controlled and prioritized by network traffic management, which also acts as a traffic controller by averting crashes and congestions, from small local area networks inside buildings to large global networks spanning continents. Efficient traffic management is essential to preserving uninterrupted functioning and smooth communication.
Limits in calculus serve as the cornerstone for understanding how functions behave near specific points. They're crucial for defining derivatives, which represent rates of change, and integrals, which accumulate quantities. Limits also determine the continuity of functions and help analyze behavior at infinity.
These are the various strategies and techniques to have an effective network traffic management using limits.
Congestion control. In network traffic management, congestion occurs when the amount of traffic exceeds the capacity of a network link or device. We can model the behavior of a network traffic using functions where the input variable represents time and the output variable represents the amount of traffic. By analyzing the rate at which traffic approaches certain thresholds or limits, network administrators can predict and manage congestion effectively.
Bandwidth allocation. Bandwidth allocation involves distributing available network bandwidth among different users, applications, or services. This can be likened to the concept of limits in calculus, where we consider the behavior of a function at which it approaches a certain value. By setting limits on the maximum bandwidth that can be allocated to each user or application, administrator can ensure fair distribution of resources. Quality of service optimization. Quality of service optimization aims to meet the performance requirements of critical applications while efficiently utilizing available network resources. This optimization involves setting limits on various network parameters such as bandwidth, latency, and packet loss. By enforcing these limits and monitoring the behavior of network traffic as it approaches certain thresholds, administrators can ensure that critical applications receive the necessary resources and prioritize their traffic accordingly.
Implementing limits in network traffic management is akin to creating an equitable ecosystem where each user gets their fair share of resources. By setting boundaries on bandwidth, data transfer rates, and concurrent connections, network administrators foster an environment of efficiency and fairness. This approach not only prevents individuals or applications from overwhelming the network, but also ensures stable performance, minimizes latency, and enhances overall reliability.